growth and decay models
Okay.
or problems.
Okay.
So none of these are super complicated. They're all pretty easy, so I think I can verbalize them.
Okay.
Um, so this one it says the growth of an insect population, and it gives the equation. It says P of t equals 500 times e to the power of 0.02 times t.
What's the general equation of continuous compounding?
Uh, P equals e to the RT.
Well, it's some initial amount, right, times e to the RT. Per is how I remember it. Okay? So this applies to any kind of growth that is continuous compounding growth, which applies to anything that changes based on how much there is there, like population. In other words, the bigger your rabbit population, the higher faster it's going to grow. You know, if you only start with 2 rabbits, there's going to be a relatively slow rate of growth, but if you start with 200 rabbits, it's much bigger. So most things in the world, whether you're talking about growth or decay, all follow this. So make sure you know this formula. That's where you can always start. And as all they've given us here is the beginning amount, which is 500, and the rate of growth, which is 0.02 or 2%. So now what's the question?
There's multiple parts, and the first one says determine the number of insects at t equals 0 days. So,
Okay, let's make sure you know how to write that. That means, what is P of 0 equal to? What is it equal to?
uh,
Don't
I
do,
would say,
don't do this on your calculator. Do it in your head.
500.
Right, because any number to the 0th power is 1. So it wouldn't matter if that was E or 2 or 2,000. If I take it to the 0th power, it's 1. So P of 0 is 500. That's the population after 0 time has passed. That's that initial population.
Right.
Okay, what's the second question?
What is the growth rate of? Okay, that I know that one.
2%?
Yeah.
In other words, that question requires you to know the general. It
Right.
requires you to know that it's e to the RT, and they're asking what is R.
Right.
It's the next question.
Uh, when will the insect population reach 800?
Okay, how am I going to figure that out?
Just set the equation equal to 800.
Right. In
And
other words, they're saying when does the population, which is P of T, that's what they mean by the population, when does it equal 800? So now there's only one variable in this, T. E
right.
is a number. So what type of mathematics am I going to use to solve this for T?
Logarithm.
Because it's an exponential equation. In other words,
Right.
whenever your variable's in the exponent, you're going to use logs to solve it. Well, I can't use logs until I get that isolated.
Right.
So what's the first step here?
Divide both sides by 500.
So I get 8/5 equals e to the 0.02 t. Now what?
Take the natural log of both sides.
Okay, what happens to the right side?
It turns into 0.02 times t.
Yeah, because I can take that exponent, bring it down and put it in front of the natural log of e, and the natural log of e is 1. So it's equal to that. So now I have this, and to solve for t is relatively simple. T is going to be that divided by 0.02. And that number you're going to get out of your calculator.
Okay.
What you get? I assume you need answers for these, so we might as well take them to conclusion, or?
Yeah,
Okay.
yeah.
In other words, if you didn't have to turn this in, this would be a sufficient stopping place, and I'd say let's go to the next problem. But
Right.
if you've got to turn something in, you might as well come up with the answer now. It's easier for you to get it now than it is later.
Yes.
So what do you get?
I got 23.5.
Did they say if t was in what units it's in? Because t can actually be in seconds, it can be in minutes, it can be in years.
It says it's in days.
Days, okay. So the growth rate then is, you might have to rethink your answer on that second question. The growth rate is 2% per day. It's not just 2% because you have to specify the time frame.
Okay.
In other words, if t were in years, then the growth rate would be 2% per year. But if we're talking about the population of insects or bacteria or bunny rabbits, whatever, they tend to grow at a rate that you measure in days. So our answer is in days. They will generally give you that information in the setup of the problem. Whether t is in seconds, minutes, days, or years. Or months. It can be in anything. Again, we have this audio static.
Yeah.
Tell me what your setup is. You have is your microphone and speakers built in, or do you have a microphone attached?
No, they're built in.
Is it a laptop? Is it a PC?
Mac desktop.
A Mac desktop with
Yeah.
built-in speaker and microphone. Where's all that static coming from? I don't think it's on my end because I don't get it with most of my students. And I don't get it 100% of the time with you. Like right now, there's none. I think we get it whenever you talk. Say something. What was our answer? T equals what?
23.5 days.
Okay, I didn't hear any static when you were talking. Let's just keep going. We can maybe isolate what the difficulty is. If your microphone and speaker are built in, there's probably not much we're going to be able to do about it, except conduct our audio by phone, which is fine with me. I have no problem doing that. It doesn't play out much different for me at all. As long as you have a phone that you can put on speakerphone, then our entire audio can be done over the phone instead of through GoToMeeting. But usually the audio through GoToMeeting is quite superior to a speakerphone, but not if there's a lot of static involved. It isn't always. So, all right. So was that the last question for that specific function, or was there another one?
One more. It was when will the insect population double?
Okay. So how do I solve that?
Set the equation equal to 1,000.
Right. Once you know the initial amount is 500, then that. So what's the first step?
Divide by 500.
Second step, take the natural log of both sides. What your answer is t going to be natural log of 2 divided by 0.02, whatever that number is. Something in excess of 23 days, I suspect. Probably like 25 days, 26 days maybe. Now,
30.
neither one of us was talking and there was a lot of static, so it seems to be random.
Yeah.
What is it?
34.65.
And again, that was days, right?
Correct.
Okay. Next problem.
All right. The population of a colony of mosquitoes obeys the laws of uninhibited growth. If there are 1,000 mosquitoes initially, and there are 1,800 after 1 day, what is the size of the colony after 3 days?
Okay. Always start these with the general formula. So the population as a function of time is what?
1,000 times E.
That's
to the power.
Yeah, that's, I'm going to call this the specific equation for this particular problem. But notice I can't solve for much with just this amount of information. I don't know the growth rate. However, I'm going to be able to figure out the growth rate because they told me that after a certain time, the population goes to what?
1,800.
So I set that equal to 1,800. And they tell me how long it took for that to happen?
1 day.
Now I have an equation that only has one variable in it, r, and I can come up with what my rate of growth is. Let's do it.
Divide by 1,000 on both sides.
Get 18 over 10, which is 9 over 5. Okay. That's equal to e to the r. All for r?
Take the natural log of both sides.
R equals the natural log of 9/5. What is that? Go ahead and do that in your calculator.
0.58.
So that's the growth rate. 0.58 is R. So now I can go back to my equation and fill in more information. Okay, now I know much more about my specific function. P of t is always equal to the starting amount, 1,000, times e to the 0.58t. Now I got something where you can give me any time frame you want and I can tell you what the population is going to be. In other words, once I solve for one of these two variables, now I have an equation that only has one variable, t.
Okay.
So what's the next part of this question?
How long is it until there are 10,000 mosquitoes?
Okay, well, I'm going to take this equation right here, which is specific, and write 10,000 in place of the population, and solve that just like we've been solving the other two problems. So you get 10 equal.
Divided by 1,000, right?
What's that? Yeah, always. In other words, you can't take the log of both sides until you get this thing down to something that looks like this, with no coefficient in front of the e or the number or whatever it is. Now, it's always e when you're talking continuous growth or decay. So
Right.
this is why natural log works so well, is because natural log of e is 1. So now I get 0.58t equals natural log of 10. I divide that by 0.58, and that's what t is. What number is that?
3.97.
And this is also in days?
Yes.
Okay, I would think so. With mosquitoes, who knows? It might be in hours. In other words, that's a pretty good growth rate. 0.58. That means 100. That means 2 mosquitoes become 3 mosquitoes every day. In other words, 4 days you go from 1,000 to 10,000. Now you know why scientists are afraid of the Zika virus. Because this is the kind of growth rate mosquitoes have. Okay, any other parts to that question?
No, not that one.
Okay, what do we got next? So the essence of all of these problems, William, is you start out with the general, and the general is actually this, the starting amount, which I call P sub 0. Okay, so this is always the general for any kind of continuous growth or decay. But then depending whether it's mosquitoes or rabbits or bacteria or radioactive decay, each one of those things will have its own specific equation where P sub 0 will be usually defined and R will usually be defined. But if R is not defined, then they give us enough information that we can calculate R. And once you figure out what R is, now you go back and you change your general equation to be as specific as you possibly can. Okay, so I'm going to erase everything except that general, because that's where we want to start everything, is with the general. And that's almost universally true with all math problems. Always begin with the general and you can't hardly go wrong.
Right.
Okay, so what's the next problem, say?
The half-life of radium is 1,690 years. If 10 grams is present now, how much will be present in 50 years?
Okay. What half-life means is that, and what they said it was 1,690 years? So
yes.
If I let t be 1,690 years, I know that P sub 0 is going to lose half of its mass. So it will become half of P sub 0 on the left side. That's all going to be equal to P sub 0 times E to the R, and here they told us that it's going to happen in 1,690 years, where t is in years. Okay? Now notice I didn't fill in the starting P sub 0, because for the first part of this problem it's not necessary. The first part of this problem, what we're trying to determine is R. Well, divide both sides by that leading coefficient, just like you have every single time. What would you get?
1/2 equals e to the power of r times 1690.
Now you take the natural log of both sides, and you get 1690 times r equals natural log of 1/2. Divide both sides by 1690, and that's what r is. And since we know the natural log of 1/2 is a negative number, and this is a positive denominator, r is going to be a negative number, which makes sense. Problem is a decay problem. R should be negative. What does it end up being here?
Negative 0.00041.
Negative 0.00041.
Correct.
Okay. Now we can go back up to our specific or our general equation again. Let's go back to it and fill in everything. They want to know when our initial 10 grams, what does it become after 50 years, right?
Right.
So they want to know P of 50. Well, P sub 0 was 10. R is negative 0.00041, and we need to solve for T. And that will answer how long it takes. No, it'll tell us how much of this material is left after 50 years.
Right.
It's going to be a considerably good amount, right? Because it takes 1,690 years for it to lose half of its mass. So in 50 years, it's not going to lose a whole lot. My guess, it might lose a tenth, but let's figure it out.
I got...
In other words, these kind of problems are two-step problems. You have to solve for R first to get the specific equation, and now you can solve for T, substitute 50, and that's what the answer is. In other words, P of 50 is going to be 10 times E to the minus 0.00041 times 50. So let's come up with that number, and that's how much you will have left at the end of 50 years. And like I said, it's going to be around 9 maybe. 9 plus or minus, maybe 8 plus or minus.
Yeah, it's 9.79.
Yeah, quite a bit. So not much of that decayed.
Right.
Lost very little in 50 years. Okay. Any other questions on that one?
No, not that one.
Okay. What else you got?
The population of a city follows the exponential law. If the population doubled in size over 18 months and the current population is 10,000, what will the population be 2 years from now?
Okay. So let's write the general. And let's see if we can figure out what R is, because they didn't tell us R. On almost every one of these problems, if they don't tell you what R is, that's your first thing you have to figure out. Because once we know R, then that takes care of one of the key variables in this problem. So you can't get very many places if you don't know R. So it doubles in 18 months.
Yes.
It starts with 10,000. Doesn't really matter. Notice that to figure out R, we don't need to know what P sub 0 is.
Right.
Because we know that if it doubles, it's going to go to 2P sub 0. So I can say 2P sub 0 equals P sub 0 times E to the R 18. Or now time is in months.
Right.
Well, again, because I'm always dividing by this P sub 0, it cancels out with this P sub 0, and I get 2 equals E to the 18R. Natural log of both sides. You get R equals natural log of 2 divided by 18. What is that number?
0.038.
And that is its growth rate per month. In other words, that's why T can be in anything, because If t were in days, then r wouldn't be this. Or if t was in years, r wouldn't be this. It's only
Right.
when t is in months, this is the growth rate per month. So now that allows me to go back and rewrite the equation perfectly specific. In other words, it's not a general equation anymore. It's a specific equation for this particular model. We're starting with 10,000, correct?
Yes.
And it's e to the 0.038t. So there is our specific equation that we can answer most any question they want answered now. What's their first question?
What will the population be 2 years from now?
Okay, so they want P of 2. Whoop, no they don't. What do they want?
24.
P of 24. In other words, I got to make sure I don't change units for time. If t is in months, I got to leave it in months. So I'm going to let 2 years be 24 months, and now I have 10,000 times e, and now that p sub 0 is very much needed. Didn't need it to calculate r, but I need it to calculate most everything else.
Right.
So whatever that number is your answer. Should be 25,000 and thereabouts. In other words,
Yeah, 24,893.
In other words, always a good idea to do a ballpark check. If something doubles in 18 months, what's it going to do in 2 years? Well, it's not going to go up by a factor of 10. In other words, it's going to go from 10,000 to 20,000 in the first 3 quarters of our time span. So it can't grow that much more after that. So that's a very reasonable answer. And that would have come into play had I made the mistake that a lot of people are going to make here. If I use 2 for t, 2 years, I'm going to come up with a number that's like 12,000 at best. Well, that can't make any sense. If it doubles in 18 months, it can't go from 10,000 to 12,000 in 2 years. So if you'd have made a mistake with the units and do a ballpark check, you'll quickly find out that you've made a mistake. You got to go back, re-examine your methodology. Where did I make the mistake? This is in months, that's in years. Cannot switch units in the middle of the problem. I could change this to 1.5 years. That might make the calculation easier, but I don't think so. It's perfectly fine to leave it in months, but then you have to make sure you turn that. Is there any other part of this problem?
No, that was it for that one.
Okay. You have one more? If you have one more, I want to see you do it from start to finish. And once you can do it from start to finish, I would say let's move on to a new topic.
Okay. Yeah, I do have one more.
Okay.
After the release of radioactive material into the atmosphere from a nuclear... Okay. Talking about Chernobyl.
Okay.
The hay in Austria was contaminated by iodine-131, which has a half-life of 8 days. If it is all right to feed the hay to cows when 10% of the iodine-131 remains, how long do the farmers need to wait to use this hay?
Okay. Tell me where to begin, what to do. I'll try to keep quiet as much as I can.
So just put P for P sub 0, or P sub 0 times
Let's start with the general. Always start with the general. It's a function of t, right?
Yes.
Okay, what is it, the general?
P times E to the RT.
And I like to put a little zero there indicating that's your starting amount.
Right.
Okay. Well, they've given us a half-life. That's going to allow me to calculate R, because they didn't give us R, right?
Right.
Okay. I promised I'd try to keep quiet. Go ahead. Go from here.
So then you set 1/2 times P equals P sub 0 times E.
Hold on. Hold on. So in other words, I know that it's going to go from whatever P sub 0 is to half of that in 8 days, right?
Right.
What's the rest of it?
Times E raised to the power of 8R.
Okay.
Actually, really quick, for this one, could no wait, never mind.
What's the time unit on T?
Days.
Okay. Keep going.
So then divide both sides by P, and then you get 2 on the left side, or what? 1/2.
Yeah, when you divide both sides by P, it's always just that.
Right.
So whatever that coefficient is over here is your answer. Now what?
Then take the natural log of both sides. And then you can change the right side of the equation to just 8R. And then divide both sides by 8.
Now what?
It is negative 0.086.
Now, let me make one comment. It's not absolutely necessary that you convert that to a decimal at this point in time. Most accurate answer is that. So if I want to know what the perfect equation is here, it's P of T equals P sub 0 times E, and R is natural log of 1/2 divided by 8. That's what R is, times T. That's the perfect specific equation. The problem with finding R as a decimal at this point is there's going to be some round-off error there.
Right.
You'd prefer that the round-off error come at the last step, not in the process of solving the problem. So there's something to be said for writing it this way. And then answering all the questions will give you a more exact answer. But I'm sure she's not going to object to finding R as a decimal right away. Now what?
Right. So
Now do we know the specific equation for this model?
yes.
That's the next step. Tell me what it is. What's the specific equation that governs this radioactive material?
P of T.
Okay, and I might even call it A of T, because that's amount. Let's call it A of T. P of T for populations, amounts for radioactive. Okay? What's the specific equation?
A of T equals A sub 0 times E to the power of the natural log of 1/2 divided by 8 times t.
Okay. Now you can answer any question they have. In other words, if they give you a certain time, you can tell how much is going to be available at the end of that time, as long as they give you a sub 0. Well, they didn't give us a starting amount here. They want to know how long is it going to take until 90% of it's gone, right? Is it 90% gone or 10% gone?
Yeah, when 90%'s gone, so when 10% remains.
Okay, so how can I take that information and use this specific equation?
Set up the equation 1/10 times A equals A sub 0 times E to the power of natural log of 1/2 divided by 8 times t.
Yeah, and this is regardless of what your starting amount is. Doesn't matter.
Right.
This equation says that the amount left will be 1/10 of what you started with. Well, the first step's always to get rid of those.
Right.
Now you have this. And there's only one variable in this equation. It's t. So when we solve for t, we'll know how long it takes for 90% of this stuff to decay. So what is it? This one, since we did this a little more precise by not rounding it off early, we're still going to take the natural log of both sides. We still have an exponential equation here where t is in the exponent.
Right.
So we still have to do this. And what's that give me on the right side?
E to the power of, or no, sorry, just natural log of 1/2 over 8 times t.
Yeah. So t becomes what?
The natural log of 1/10 divided by the natural log of 1/2 divided by 8.
Got to multiply by 8 first.
Oh, okay.
So that gets rid of the 8. And then I got to divide by the natural log of 1/2 to get rid of that. In other words, to isolate t, I got to get rid of the 8 and I got to get rid of that. So I got to multiply by 8 and divide by natural log of 1/2. Gives me that. And I can actually take that 8 and put it up here so it's the natural log of 1/10 to the 8th power. But I don't have to compress it that much. That would be its maximum compression. Which takes me back to that last problem you gave me last night, which was rather clever. If I have something like this, how can I compress that further? That's the natural log of x divided by h. Are there any other questions with this problem we're on?
No, that's it.
Let's talk about this. This
Okay.
was something I had never seen before, really. In other words, if I have this and I want to compress it, the first step is to take that h and make it a multiplier. Is that not the same thing?
Right, yeah.
Now I can take whatever the coefficient in front of that natural log is and make it an exponent. So that is natural log of x to the 1h exponent, 1 over h exponent. So that was the tricky part of that last problem, was taking the h out of the denominator, turning it into a multiplier as a reciprocal, not the reciprocal really, 1 over 8, and then turning that into the exponent. So that's a useful thing to know. The problem you gave me last night was the only time I've ever had to use that principle, but
Right.
it was still clever. I'm not sure I'd have found it on my own had they not given us the answer and said, prove that what you have is the same as this answer, which I like the way they did that, because that wouldn't be that easy to find on your own. If they just said, what's that thing equal to, you'd leave it like that, probably.
Right.
I would never think to take that H and turn it into that, unless they told me, prove that this is the same as that, and then I'd do it. But all right, what else you got?
Growth of bacteria.
Okay.
The number n of bacteria present in a culture at time t in hours obeys the function n of t equals 1,000 times e to the power of 0.01 times t.
Now see here, they gave us the specific equation. They didn't give us anything that required us to calculate R. Everything that they gave us, this is the specific equation, and you give me any time frame and I can tell you how many things there are. What is this, the growth of?
Bacteria.
Bacteria? Okay. So how many bacteria do we start with?
1,000.
Okay. What's their first question?
Determine the number of bacteria at 0 hours.
Okay, so n of 0 we know is 1,000.
Right.
Because that's, if I substitute 0 for t, this whole thing goes to 1. Okay, what else?
What is the population after 4 hours?
So how do I get that?
Plug 4 in for t.
So I want n of 4. Trying to get you used to this notation. Because that notation becomes fairly important when you get to calculus, where if you're trying to evaluate a function at some whatever value, you write it like this. Okay?
Okay.
What's that number?
1,040.81.
1,040.81, and that was after 4 days?
4 hours.
I was going to say, that doesn't sound like any bacteria I know of. Okay, so after 4 hours it's grown, but not outrageously.
Right.
Because its growth rate is only 1% per hour.
Right.
So it's not a fast-growing bacteria. What else do they want to know?
When will the number of bacteria reach 1,700?
Okay, let's always, when you get a question like this, you want to back up to the specific equation which they gave us. So what am I going to write?
1,700 equals 1,000 times e to the power of 0.01 times t.
Now what?
Divide by 1,000. And then take the natural log of both sides.
On the right side?
You're left with 0.01 times t.
What's t end up being?
53.06
hours. So in a little more than 2 days, it goes from 1,000 to 1,700.
Okay.
Wondering, that's probably a cold virus. They say it takes a cold, when you catch the initial virus, it takes 3 to 7 days for symptoms to develop. So it must not be, that virus must not be that rapidly multiplying. I don't know. I'm just theorizing there. But as long as we understand what we're talking about here, as long as t is in hours. Okay, what else do they need to know about this problem? Anything?
No, that was it.
Okay. I think you're pretty good on these exponentials. Growth and decay.
Yeah.
You sure you don't want to go to a different subject matter for our last 10 minutes?
Yeah, I just flipped to a new page.
Okay.
So it says, find the equation of the parabola described.
Okay.
Find the 2 points that define the lattice rectum and graph the equation by hand.
Okay.
So it gives the focus at 4, 0 and the vertex at 0, 0.
Give me the general equation of a parabola. Whatever they've taught you, use. Because there's two different ones.
Yeah, they just taught us one today. Y minus k
times 4p.
Where does p come from?
That's the focus. So they didn't teach you this one?
No.
All right, so the one they taught you is this one. And then they said A is equal to 1 over 4p. In other words, this is actually the same as the vertex format. Notice that if I add k to the other side, I get y equals your vertex format. Perfect.
Right.
So they're leaving it in vertex format. They're not giving you a new format that is different than the one they've always worked with. That's fine. We know what p is. P is 4. If we draw a picture of this thing, our vertex is at 0, 0, and we know it opens up because, oops, excuse me. This has to be a horizontal parabola. Because I know my focus is inside my parabola, and that point right there is 4, 0. So if my focus is on the x-axis, then there's no way it can be a vertical parabola. It has to be horizontal. And it has to open to the right because the focus is always inside the parabola, not on the other side. Okay, so they want to know the lattice rectum. I just love how anal math is. It seriously is. I mean, I can tell you 4 or 5 different terms that are all anal, and they all have nothing to do with anything but math, but makes you wonder where they came up with these words. The lattice rectum is this measurement right here. It's the distance between the 2 points of the parabola. If you draw a line that's parallel to the directrix, here's the directrix. The lattice rectum is always parallel to the directrix and goes through the focus. Furthermore, the width of it is 4 times P. That is the width of the lattice rectum. Well, what's P?
4.
So what is that's what they wanted, was the width of the lattice rectum? What is it?
Yeah, it's 16.
16, exactly. Which means it goes up to 8 here and goes down to 8 minus 8 there. That would be a width of 16. Anything else they wanted to know about this?
No, not for this one.
Okay. Made a mistake here in our general formula. This is the general formula for a vertical parabola.
Oh, right.
General formula for a horizontal parabola is x equal y squared. So I have to do some manipulations here. This is not the correct general formula. I just assumed it was going to be a vertical parabola. But based on this information here, I can figure out that it's a horizontal parabola. There's no way I can have a vertex here and a focus there and have it be a vertical parabola. So I want to make sure I use the right general equation. So let me go back. Let's see. For me, it would be 4p times x minus h equals y minus k squared. That's my general.
Right.
And notice that I'm looking at x equals y squared. The way you can always tell is what you've learned for 3 years is y equal x squared, right? So you get the reverse of that when it's the y that's being squared and the x is not, and it's a horizontal problem. For this particular problem, it didn't really matter because we knew what focus was, and we knew that the lattice rectum was 4 times the focus. So I was actually able to solve this problem without the correct general formula.
So
which is fine, but if they ask any more sophisticated problems than what they did, I'd have to make sure I had the correct general formula, which is this one here. And I don't have to have the 4p over there. I can have the a right there, if you prefer. In other words, if they haven't given you anything that looks like 4p, then go ahead and use the a in front of the y minus k squared, and notice that as long as a is equal to 1 over 4p, I can divide both sides by a, and I end up with 4p there and no a. So this tends to be the general format for most school systems when talking about parabolas as conic sections.
Right.
And the vertical one would look like this. 4p times y minus k would be equal to x minus h squared. So there's your general for a horizontal one, there's your general for a vertical one. And if you don't want to use a and do the conversion, in other words, you can always use the one you've always used, but then you're going to have to always figure out focus based on this relationship. So to avoid that and to make it look a little nicer, they move the 4p as a coefficient in front of the other side. Because the problem almost always is to figure out the focus. Even in this problem, we had to figure out the focus. You can't get the lattice rectum length without the focus. So you're always having to figure out P, or at least plug it in. knowing what it is. And whether you use this general format or the one that has the A, doesn't really matter. I've actually found that it's a little easier using this format with 4P. Just
Okay.
maybe it's because most of the school systems I work with use this format, so I've gotten used to using this format, but that's not to say you have to. You know, you can use the A. The A goes in front of the term that's being squared. The 4P, if you're going to use that, always goes in front of the term that's not being squared. In other words, that's the general format, or I'm going to put the A there. That's the general format. So both of these are correct, but then you have to make sure you know that A equals 1 over 4P, which also means P is equal to 1 over 4A.
Right.
Those are true. All right, Michael, or excuse me, William. It's been a long day, and I'm not even close to done. I'm just hoping my voice holds out. It's starting to get a little hoarse. All right.
Can I do a quick conceptual question?
Yeah, I do have a 7 o'clock, so I don't have a lot of time, but I'll answer it as fast as I can.
So you said y squared equals x is a horizontal parabola.
Uh-huh.
So that's the same thing as y equals the square root of x, but they have different graphs.
Not really. It's the same thing as y equal plus or minus the square root of x. If I start with y squared equals x, and I take the square root of both sides, and I get plus or minus the square root of x. Okay, if I graph that, there's the plus side.
Right.
There's the minus side. It is not a function. It is a composite of two functions. In other words, my parabola is made up of the square root on the top side and the square root on the bottom side. Believe it or not. That
Okay.
curve is exactly the same. That part of the curve is exactly the same as y equals the square root of x.
Okay.
Always,
Okay. Thank you very much.
always remember, when you're taking the square root of both sides, start your answer out with plus or minus. All right, William, I will talk to you tomorrow whenever your session is.
I think it's 8 o'clock.
Talk to you then.
Great. Thank you very much.
Bye-bye.